morning. Now, today we will begin our class 1 on your paper Nuclear and Particle Physics. Now, I will be teaching you Unit 3 Nuclear Reactions. So, this is the first class on that unit. For this unit, that is for Unit 3 Nuclear Reactions, the reference book that is prescribed in your syllabus is Introductory Nuclear Physics by Kenneth S. Crane. So you can refer that textbook, and what I am presenting here in throughout the class will be from that book. Okay, so you can refer that book for this session, that is nuclear reaction. So in that book, I think it is chapter 11. Okay, so just go through the contents of that book and you can see nuclear reactions mentioned in that. Okay, so Introductory Nuclear Physics by Kenneth S. Crane. So in the beginning, just an introduction. This is a topic that is mentioned in your syllabus, that is types of reaction and conservation laws. Okay, now a nuclear reaction is usually represented as A plus X is equal to Y plus B. This is a usual notation. Here A is the accelerated projectile, X is the target, then Y and B are the reaction products, that is the products that is formed after the reaction. Usually this Y is a heavy product that stops in the target and it is not directly observed, whereas B is a light particle and that can be detected and measured. Here A and B are actually nucleons or light nuclei. Sometimes B will be a gamma ray. So if that A and B, we know it is nucleons or light nuclei. In some cases B will be a gamma ray. If B is a gamma ray, then we call the reaction as radiative capture. Okay, now if A is the gamma ray, then we call the reaction as nuclear photo effect. Now, the above reaction, that is A plus X is equal to Y plus B, can be represented in a more simple form as X of A comma B equal to Y. So, you might have seen some examples like alpha N or N gamma reaction. So, that is another way of representing a nuclear reaction. Now, reactions can be classified in many ways. That is, suppose that the incident and outgoing particles are the same, then you call it as a scattering process. Now that scattering process will be elastic if Y and B are in their ground state, and it will be inelastic if Y or B is in the excited state. Okay. Now in some cases A and B that we have already discussed will be the same particle, but the reaction causes yet another nucleon to be ejected separately. In such case, we call the reaction as knockout reaction. Now, another reaction is a transfer reaction. It is a reaction in which one or two nucleons are transferred between projectile and target in such a way that incoming deuteron, that is one example is quoted. So, transfer reaction means it's a reaction in which one or two nucleons are transferred between projectile and target. Now, they have given an example, that is, in some cases you might have seen that an incoming deuteron turning into an outgoing proton or neutron, thereby adding one nucleon to the target X to form Y. That is a deuteron changing. That is, deuteron which is coming into will be converted into a proton or neutron as it goes out. Okay, that process just adds one more nucleon to the target nucleus X to form the product Y. That is a meaning. Okay. Now reactions can also be classified depending upon the mechanism that governs the process. For example, in direct reactions, only very few nucleons take part in the reaction, with the remaining nucleons of the target serving as mere viewers, that is spectators. Okay, now such reactions might insert or sometimes they will remove a single nucleon from the shell model state and will help us to explore the shell structure of the nuclei. Then what is compound nucleus mechanism? It is the one in which the incoming and target nuclei merge or combine briefly for a complete sharing of energy between outgoing nucleon is ejected. And that is similar to the process of evaporation of a molecule from a hot liquid. Now, in between this direct reactions and compound nucleus for mechanism, that is, these are the two extremes. So, between these two extremes, there exist resonance reactions. Okay, that is between direct reactions and compound nucleus mechanism, there exists resonance reaction, and it is the reaction in which incoming particle forms a quasi-bound state before the outgoing particle is ejected. So these are the various type of reaction. How a nuclear reaction is represented, and what is elastic scattering, inelastic scattering, what is knockout reaction, what is transfer reaction, what is direct reaction, what is compound nucleus mechanism, then what is resonance reactions. Okay, these are a few definitions. Now the last one is the conservation laws. First is the conservation of total energy and linear momentum. This actually helps us to relate the unknown but measurable energies of the products to the known and controllable energy of the projectile. That is, the unknown energy of products can be related to the known energy of projectile by using law of conservation of total energy and linear momentum. That is, we can use the measured energy of B to work out or to calculate the excitation energy of Y or the mass difference between X and Y. Next is conservation of proton and neutron number. Now, it is a result of low energy of the process in which there is no meson formation or in which there is no quark rearrangement. Now, at high energies, total nucleon number is conserved, whereas at low energies, proton number and neutron number are conserved separately. Now, conservation of angular momentum, it relates spin assignment of the reacting particles and orbital angular momentum carried out by the outgoing particle, and this can be deduced, or that means it can be calculated how by measuring the angular distribution of the particles, that is angular distribution of the reacting particles and the outgoing particles. Using this conservation of angular momentum, we can also calculate the spin assignments of nuclear states. Then the last one is conservation of parity, and that is here parity conservation law states that the net parity before the reaction must be equal to the net parity after the reaction, that you all know. And suppose that you know the orbital angular momentum of the outgoing particle, then by using -1 whole raised to L uh, rule and the other known parities in the reaction, we can, by applying that rule, we can calculate the unknown parities of the excited state. Okay, that is -1 by raised to L rule can be applied to calculate the unknown parities of the excited state. That is, by using that rule and the parities of the known states, you can calculate the parities of the unknown parities of the excited state. So these are the conservation laws that you have to mention: conservation of total energy and linear momentum, conservation of proton and neutron number, conservation of angular momentum, and finally conservation of parity. Okay, so for the first class, this is enough. Okay, thank you.